Good morning, guys. Welcome back to DevOps sessions. So today we are at day 3 or day 4? Day 3, huh? Okay. Tomorrow is holiday. Monday is holiday. Tuesday class will be there. Okay. Let me change chart, everyone. Okay. Am I audible, guys? Online team. So I have already shared day 1, day 2 notes, Kubernetes. Okay. Just go through it once. If you have any questions, can you stop that? Okay. Let me share my screen. Okay. So guys, we'll discuss components in the worker node components. Then we can see the installation process and all. So here, first two things we need to understand to practice it. So we can do it by using Minikube concept. The Minikube concept is not for real environment, just for practice only. Okay. If you install Minikube in your local laptop, it will provide Kubernetes platform to do the practice, but not in real time, just for practice only. Real time, we will work directly EKS cluster or AKS cluster or GKE cluster. Okay. But to do the practice, yes, we can use Minikube for 1 or 2 days. Then we can go for actual cluster process. Okay. So what is Minikube here? Sorry. So if you can go here, so the Minikube, so Minikube is a tool that set up a Kubernetes environment on local PC or laptop. Just for understanding statement, if required, you can follow it. And then installation process is important. First, I'm going to install Minikube in my local laptop. I mean instance, AWS EC2 instance. Then Minikubes will run. Minikube will run means we can able to do the practice of your Kubernetes. So guys, in the Docker, the all commands we can run by using Docker, right? So Docker run, Docker images and everything, every command, there is a Docker command before. In Kubernetes, in every command, it will start from kubectl or kubectl. Okay, kubectl or kubectl. So kubectl is a Kubernetes specific command line tool like a Docker that lets you communicate and control Kubernetes cluster. I mean, whenever the request will give from the kubectl create, the request will go to directly API, control API. Same in the Docker, the request will go to directly Docker daemon. Okay. So kubectl is interaction from your local request to your remote. Okay. If request will go, create pods, delete pods. So the communication will go through kubectl. Okay. So in the Minikube. So here two things we need to understand. Kubectl is a common interaction, common communication for any process. If it is a Minikube, if it is a EKS cluster, or whatever it is. But if you can do the practice in EKS cluster, you need to install EKS. Okay. If you're doing practice in Minikube, you need to install Minikube in your local. Let's do with Minikube first, then we can go for EKS cluster. Okay. So to Minikube, this is the installation process. Call this command and sudo this command. Let me install this first. The prerequisite Docker should be there first. as yesterday discussed, right? Any Kubernetes commands, it will run directly into the runtime, right? So if there is no Docker means Kubernetes will not run Docker container directly. Okay, let's go here. Sorry. So if you can see here, my instance. So I'm in London. Let's go to North Virginia. Sorry, my screen is stopped. Okay, if you can see here, Jenkins. Guess my screen is visible, online team. Sorry, I have changed the chart now. Yeah, okay. So let's connect server. Okay. Okay, I'm in the root. So Docker already there in my end. If you want to check Docker version. So Docker client and server is up and running in my end. So now, yes, if I want to start work with Minikube, you can install Minikube here. Or if you want to work directly into the cluster, you can create EKS cluster. Anyway, just for understanding practice, we can go for Minikube for today, and Tuesday we can start directly cluster. Okay. Yeah. So the installation process of Minikube is once again, I'm saying that Minikube is for to do the practice in local environment only. Just copy this command and then okay. And next command is install Minikube with the repo and move to Minikube into the bin to run command into the bin directly. Okay. After that, you can start Minikube. So if you can go for Minikube start process to start Minikube. To check the status, Minikube status. To update Minikube update context. Like this you can give. So Minikube start. Minikube status. Start Minikube, I think. Excuse me. Let's go and check. Okay. Let me let's go here, check. Rename. I will give in. Let's go and verify first. Excuse me. User local bin Minikube. Minikube is here. User local and ls bin is there. CD bin. Excuse me. Yeah, Minikube also there. Okay. Yeah, perfect. So guys, now okay. So before start to the practice, Okay. Before start to the practice, we need to understand worker node components. Very, very important. So no need to focus on control node. The reason it is taken care by cloud. So on worker node components, what are the components we have in the worker node? We can discuss first. So worker node components, let's go for remove this. Okay. In worker node components, mainly we have pod. Okay. And deployment or replica set. And 3, deployment. Okay. This 3 is very important. Pod and replica set and deployment. So what is pod? So pod is a abstraction layer of container. Okay. Not required just. So mean the pod layer will come after on top of the container. Okay. Inside container image. Not required if permission is there. If permission is not there, we need to. Okay. So guys, simple. I will show you one pod YAML file here. Okay. So that you can understand how to write. So let's go to first. Worker node components. Just go for here inside pod. Copy here. So pod.yaml. You can give any name, no problem. YAML file name. Just okay. So guys, we need to understand any YAML file in the Kubernetes. If you know this YAML file, you can easily write other YAML files also. Even you no need to remember, just I'm saying that for understanding purpose only. So in any YAML file in the Kubernetes, the first, it will start from API version. Okay. So here the versions only 2 types, V1 and apps V1. Okay. So it will change deployment and services, different YAMLs we have. As per the YAML instructions, the version will change. We need to focus. Here we are using API version is V1. API version is V1. Any YAML file, the first one is API version. Key name. Value should change. Depends on your YAML file. Is this clear, everyone? And next one is kind. What kind of YAML it is? What you are going to create now? Just I'm going to create pod. So kind would be pod. P should be capital. Okay. And next, metadata. So metadata is nothing but the name of your pod. You can give any metadata, data about data. So name of the pod is my app. And label of my pod, the label of my pod is this one. I will tell you what is label. Okay. So the first one is version, common for anyone. any YAML file. Next is kind. We need to define what kind of YAML it is. And metadata. Metadata is nothing but labels and name of the pod. Here, if you can see here, my name of the pod is my app. Okay, name of the pod is my app. Label of my pods is app, web app, or type frontend. You can give any name. It's a key value pair. I mean, you can give name colon test, name colon dev, whatever. It's a pair. Okay, key value name. This is key name. This is key name of value. Understand? Okay. Sir, what is the use of labels? So anyone? Already I discussed, right? What is the use of label? Just high level we discuss, right? Okay. So guys, for example, you need to give this pod public access. Understand? For that, what you need to do? Create a service YAML. That already discussed, right? Service YAML is help to give access. The types of services, node port, load balancer. Anyway, there is a special class on that. So yes, in your end, for example, 4 YAML files are there. One is Nginx pod. This is Nginx pod. And other is HTTP pod. Other is whatever related pods. But I need to give only Nginx pod to access. Then how you can communicate by using your service? Out of 4 files, you should give only 1 pod access to outside. 4 pods, different files. But you are creating one service to give only 1 pod access, not for remaining 3 are different applications. So how to communicate? In that case, labels will help. In the service, if you pass these labels, service can understand, okay, I should talk to this pod only. I should divert to this pod only. Understand? Interview question. How can you ensure your service should communicate with your pod based on the labels? Clear? But we are not using any label. We are not creating any service. At this time, you are not creating. But if you create in the future, use this label into your service. For example, if you're not define labels, no problem, your pod will create. Labels is optional one. If you want to connect this pod by using service, at that time you need to add changes into your pod also. Why? If there is no labels here, you need to add labels here and pass that label into service. So define labels before, no problem. In future, if you want to call, you can pass this label into your service. That's it. No need to disturb your pod. Clear? And metadata, so the labels and names comes under metadata. Okay. So the name is nothing but here what? Your pod name. This is your pod name. Okay. This is your pod name. If you can give command to check your pod, you can able to see your pod name is my app. So labels, your pod name comes under metadata section. We have 3 sections. One is API version, one is kind, one is metadata. Is this clear? This 3 is common for any YAML file. Deployment, replica set, pod, horizontal pod auto scaling, service.yaml, whatever, this 3 is common. API version, kind, metadata. Okay. So till here, we are specifying your pod details only. But actual here the thing is this one. What is this one? Image. Okay. This image is public image. no private image in Nginx. If you want to call your project image, you already push some application to ECRs, right? Take that URI of ECR image. Give here only. Rest all same. No need to change. If pod created means, let's suppose you are creating pod. You are creating pod. Okay. Inside pod, container. Inside container, image in the form of application. Let's say image. Okay. So inside container image, this is container, this is pod. Guys, you tell me if you create a pod YAML file. Pod YAML file means definitely in the YAML container will be there, right? And image will be there. Then only pod can create. So definitely in my pod.yaml, in that case, definitely container details I need to define. I need to define image details also. Image details I can take from where? Docker Hub, your private Docker Hub registry or ECR. Clear? Now, whenever you can give a image, that image, if you run means container will create in the Docker. But here, yes, container in the form of pod, it will create. Why? You are running through Kubernetes, not for Docker. So whenever you run image, definitely container will create, right? Whenever you create image, definitely container will create. This container name we can define here. And which name container should create? This is the container name. So the important things here comes under spec. Spec means here specifications of your image and containers. Clear, guys? So if I'm talking about pod, definitely container should be there, inside image should be there. See, this is the architecture. Now I'm creating pod means now what I can do here, I just map it like this way. This is pod details, right? Okay. Now this is container details, right? Now this is image details. Is this clear? Yeah. But in real time, nowhere we can use pod YAML file. Any reason? Why? Why? Yeah, it's not temporary. How many pods can create? One. So we cannot scale and scale out here by using the pod. Understand? Whenever I apply this YAML, we'll create only one pod. If you want to increase the pod scale 2, 3, not possible from the pod.yaml. In this, there is no replicas information. Replicas means we can create 1 or 2 or 3. Understand? So pod YAML can help to create only one pod, not multiple pods. That's what we are not using pod.yaml anywhere. Clear? Yes. Next worker node component is replica set. Okay. So we can take replica set.yaml also. Let's paste it here. Okay, guys, if you observe here, you can easily identify what happened. So you can easily identify one thing. Here, okay, okay. What happened, guys? Okay. So here, okay, if you can see the replica set carefully, we can easily understand one thing. Okay. The first important factor is what here? Replicas. Replica set means replicas will provide. But in the pod, we'll get only one pod. If I deploy this replica set, I can create 3 pods, not one. Clear? If you give 3, 4, 5, 6, 7 here, 7 pods will create. So this 7 pods means if you create one, if you delete one pod, actually in the replica set, it should be maintained 7. Or in this case, 3, right? It should be maintained 3 replicas. If you delete one pod means immediately one more pod will create. Why? It should maintain 3. See, 3 pods should exist at all times. Then who can monitor 3? For example, one pod is deleted. Who can monitor this system? Very good, controller. What is the controller state? Desired state, current state. What is my desired state here? 3. But current state 2. One deleted immediately. It will create one more pod with the same YAML file. Understand? Yes. And yeah, if you observe here, as I said, any YAML file will start from API version. We have 2 type of API versions only, mostly V1, apps V1. If it is a pod, V1. If it is a replica set, apps V1. Understand? It's fixed. And next one is what? Kind. Here is not pod, right? Here replica set. In YAML, what you are going to create, you should give in the kind. You are going to create replica set, then give in the kind. Now, what about metadata? Metadata contains what, guys? Name and labels. Clear, guys? See, my replica set name is what here? Web RS. Web RS. Okay, perfect. Yeah, if you can see here in the spec different. Here the spec is container and image details are there, right? Now here there is no spec. The reason here there is no replicas. Directly it is go for image details. But replica means what it does. First it should give the replicas. So the replicas comes under spec. Okay, here pod there is no spec here. It depends on container and image only. But here replica set means what? It will create 3 replicas, 4 replicas, 5 replicas. So we should give in the spec. And what is the labels here? Label selector, match labels, app, web app. Means what? These labels is for replica set labels. This labels is for pod labels. Understand? So these labels are for replica set labels. These labels are for pod labels. So now go for template. What you can understand after seeing this? Hmm. What you can understand? Excellent. This is pod information. Understand? So we can the same thing is there here, right? Same, right? Is there any difference here and there? See here, metadata, pod labels, type, replica set label selector. If you can see here, containers, image, pod, same. But here one difference is there. Yes. Replica set giving 3 replicas means on top of the which pod? This pod, right? So how replica set link with this pod? Based on the labels. At least should match one label. Here 2 labels are there, right? In pod. One label is app web app type front end. At least one match means in the replica set, you should define the replica set selectors same name, at least one, or type colon front end. So if you give this match only, your replica set can apply the replicas concept in your pod. Understand? These labels very important. Whatever labels are there in the replica set, you should match. Yeah. Now let's take this. How many pods will create? 3, right? Clear? So what is this? Load balancer. Did I say any load balancer concept here? Replica set. Okay. In the replica set, if you can give 4, fourth pod will come here. Clear no? And next one is deployment. Simple. Just replace with replica set in place of deployment. That's it. No change. Okay, let me show you if required. So this is deployment. So everything is same. If you can see, only change is kind. Okay. So just leave about these port numbers. Okay. So I will take one class, especially in the network. I will cover what is container port, what is cluster type, and everything we can cover in that. So here and there is no difference, guys. If you can see here, everything is same, but the only difference is in place of replica set, deployment is coming. Even version also same. Okay, even version also same. But what is the advantage? Then why deployment here? Then why deployment here? Yeah. So our agenda is to create multiple pods that replica set is giving, right? Then why again deployment? So there is advantages are there if you can go over the deployment. The reason If you want to upgrade your application, if you want to roll back your application, updates, okay, updates, we can do it if it is in the deployment only. Replica set, we cannot do anything. We can increase the pod, we can decrease the pods, but we cannot upgrade the applications pods. Okay, rolling updates not possible in replica set. Rolling updates possible in deployments only. Okay. Sir, what is rolling updates? We can discuss. So one worker component is pod, one worker component is replica set, one worker component is deployment. Can I use both replica set and deployment? Can I use both replica set and deployment? No, right? Both are doing same task. But here deployment, there is advantages. So should not use replica set if you are using deployment. So if you can see in deployment also replicas are supporting here. Understand? This is the difference. Okay. Any questions? Worker node components, main worker node components, these are. So if you want to deploy anything, any application, in that case, you need to use deployment.yaml only. Yeah, okay, Arun. So here the replica set is, if you can see here in the pod, there is a drawback. The pod YAML, there is no specification for replicas. Okay. Pod itself will not give to define replicas in the pod YAML. So this is for temporary only to check the pod only, pod YAML. But see, as we know, the application definitely will support high availability. If you go for pod.yaml, that application will support only for one pod. If the pod will down means your application is not high availability. In that case, definitely, even ESOT instance concepts also, we configured auto scaling. Okay, we configure load balancer. So here, auto scaling concept we can achieve by using replicas. Okay, if you define 3, 4, 5, immediately 5 will be created. Okay, no need 5. You can change replicas into 1. You can reapply. Immediately 5 will be deleted. I mean, by using this pod, we can create only one pod. By using this replica set YAML, we can create 3 pods. That is the difference, only replica set and pod. So that definitely replica set, we need to map a labels. Which pod I can create 3, which pod I can create 4. In that case, definitely have to give this labels mapping. That's what I have written. Pod label should be defined in replica set label selector. This is the pod label. And type is front end also have given. At least one pod label should match with the replica set label selector. Guys, this is not, this is comes under this statement, okay? There is no any definition for replica set label selector separately. What you need to understand it will come cover here like this way. Okay. Yeah. So in the spec, normally, so this is enter pod. This is enter pod. So in the pod, we have to map with the labels and define replicas. So here only additional thing is what here? This one only. Understand? That's what I'm saying, right? We are creating pods by using replica set only now. By calling labels. By calling labels. See, if you just example, guys, without labels, okay, just understand. In your directory, different amplifiers will be there. In that case, how you can define to your replica set? You can go on, you can just create 3 pods, 4 pods for only this application. How you can define? So in this directory, only one ample means maybe, but 3, 4 means it should apply for replica set only for that pod only. In that case, definitely we need to call labels. Okay. Yeah. Is this clear, everyone? Okay. And the next important is horizontal pod autoscaling. Horizontal pod autoscaling. So let's go to horizontal pod autoscaling. Where? Horizontal scaling. See, if you can see this, just go for next slide here. I'm just explaining today's only theory for the components only, okay? These concepts are very, very easy, guys. What is this? Horizontal pod autoscaling, right? Okay. So let's go here. Copy. What is this? Deployment dot YAML. So it will create Nginx pods. How many? 3. In this case, guys, if you can see in this case, these replicas are static or dynamic? Static. Definitely static. It's not depends on the load. Your controller always check. This is Kubernetes, for example. Cluster. So in between your controller, okay, always maintain desired state, current state. Okay, in this case here, pod 1, pod 2, so pod 3. Okay. Pod 3. So this is desired state. This is control state. Sorry, current state. So in this state, if any pod is deleted, automatically create one more pod by using controller. Controller always just monitor desired state to current state, like a state file, Terraform. Okay. Yeah. If 3 pods are busy with your requests, okay, I need 4th pod. Is that possible? Dynamically, statically possible. What I can do? I can increase the replicas through command. There is a command to increase the scale up, scale down. No need to come YAML file. Scale up command, if you can give automatically, how many, if you can give the scale up max is 4, if you can give, it will increase to 4. Scale up, scale in, you can give the command, it can vary the replicas. Otherwise, you can come to YAML file, change the number, apply. Apply means it will not create one more different pod. Same pod, update the replicas as per the state architecture work process, right? It will not create same YAML, right? So already pods are running, no need to create new. There is update only. You can update it. Clear? So now in this case, yeah, in this case, how I can dynamite the process here. So here the static process, I want to convert into dynamic process. So convert into dynamic process, you can compare with your auto scaling concept. In auto scaling, there is a 2 type of scaling, static and dynamic. In static means scheduled based scaling. Whenever the time will come, it will create the pods, not depends on the load. Or manually, if you can define max, minimum means manually, it will create 4, 3, 5 like that. But dynamic process, so we have given one set point, right? Minimum max depends on the which factor? CPU utilization, right? So whenever load increase, your CPU will be varying. So based on the CPU utilization, we can give the set point so that auto scaling will follow the same thing, right? In the auto scaling process. But here everything we can handle by using YAML files only, right? By using YAML file, we can handle the same process here also. So in this case, horizontal pod auto scaling will come into the picture. So let's paste it here. So every YAML, the process is same. Start from here. If you can see, auto scaling V2 version is, it is doing auto scaling process, right? So now, yeah. Yes. So if you can see here, what we can observe here, minimum and a maximum depends on your CPU resource. What is my target? CPU utilization. Okay, what is my target? CPU utilization resource. What is the set point here? 1%. 1%. Understand difference? Same steps we have given in auto scaling, right? Minimum, max, percentage, and CPU. Here we are giving in the form of YAML. Okay, here we are giving form of YAML. Okay. So yes, there is a mistake in this. Can anyone identify the mistake? Horizontal auto scaling and deployment at YAML. No, that is correct only, but there is some mistake. So horizontal pod auto scaling definitely apply for your deployment. So this guys, static means what? You can come and increase or decrease. But this task someone has to do dynamically. Understand? That is horizontal auto scaling. Your horizontal auto scaling can monitor, can increase or decrease the replica count based on the CPU utilization. So I'm saying here, my horizontal pod autoscaler, you can increase my replica set till 10. You can decrease till 1 based on the load of the pod. Then how I can say to this horizontal auto scaling, you can go and talk to only this deployment? Name here. Understand? We need to call, hey, horizontal auto scaling. This is my deployment. You can increase, decrease based on the CPU utilization. Okay, give me the deployment file. I can do it. No need to do it by statically. I can just implement dynamic process. Then in that case, what I need to give? So this is my target. This is my target. You can take reference from here. You can take reference from here. Okay, let's go to your horizontal auto scaling to verify where is my deployment.ml. We have given this is the API version, this is the kind deployment, this is the name. It will go on check is there any deployment is there in the Nginx-HPA. So is there an Nginx HPA is there? But what is the name actually? Nginx deployment, not label, name. Nginx deployment, but here is there Nginx HPA. So it should be change deployment or it should be change HPA, whatever. Okay. So you can write HPA, Nginx HPA. Clear? So now this value always will vary. Okay. Who can do it? Horizontal autoscaler. So horizontal autoscaler always monitor CPU load. Based on the load, this value can give to here, the value. Okay. Hmm. Sorry. This is metadata is horizontal autoscaling metadata. We are calling which metadata? Your target deployment metadata. Here should be match. That's what here Nginx HPA is there, right? That's what I have added Nginx HPA here. Otherwise, we can remove HPA, add right deployment here, Nginx deployment. You should be match here, target deployment name and the horizontal source deployment name here, whatever you have given. Only we are calling this name only here, simply. Understand? So we are calling here this only. Okay. Clear? Yes, same, Harshal, correct. Yeah, good question from Vinay. Guys, tell me one thing. This is minimum or maximum, whatever you are going to define into that. Very good, desired. That is there in your auto scaling, right? Whenever you can create auto scaling group, immediately 2, 3, 4 will create. That's a desired set point. This is desired. This is minimum. This is maximum. This is set point. Clear? This is dynamic process. So in interview, definitely today class and yesterday class, you will get 2 interview questions. Sure about that. And last, very important component is it's not files, status of pod only. It will not monitor files, Nagaraja. Status of pod, running or not. That's it. Okay, then. So anyway, we have a monitor system. We have a logs monitoring system. We have a many things are there. We need to configure with your cluster. Okay. And so the next one, very important one is service. Worker node component service. Cluster means control node plus worker node. Control node not in our control. We are going to deploy our pods and all in worker nodes. Okay. Okay. So worker node components. Let me do one thing. So if you want to check that, so I'm going to create one cluster in Mumbai region or US East one. Okay. So these are the prerequisites we need to take care. We have to create IAM user. Okay. Or in your ESOT instance, we can create a role, attach role for admin access or EKS permission. Okay. So let me create this one first. Meanwhile, it will take some time. Then we can discuss service concept. So there is a cloud formation stack process in the AWS. So in AWS, like a Terraform, it will support for all clouds, right? If you want to create an infrastructure, we are using Terraform, right? So we are giving one command to create EKS cluster. The background two instances will create. The two instances work like a worker nodes. It is comes under EKS. So the regarding infrastructure, everything can create by using cloud formation template. Here, cloud formation template is nothing but same kind of Terraform. It is a AWS service. Like Azure service also, Azure VM, Azure RMs are there. Okay. I mean, Terraform is a third party tool, but same infrastructure as a code process. Each cloud, there is a separate process. AWS is a cloud formation template, Azure different, GCP different. But in organizations, we are using only Terraform mostly 90%. Okay. No need to learn cloud formation. But this is AWS, right? So we are giving to create AWS by using CLI command. The background, it is going to take help of CloudFormation template to create the EKS cluster and required resources. That is AWS system can take care. No need to do anything from you. How they are creating cluster, we are giving only single command, right? They are configure the system background to create EKS cluster with that command. Anyway, to create it, I'm creating from this server, right? This server should require first EKS permissions. For that, we can create a role and add EKS permission to that role and attach it. And that role, we have to add cloud formation permission also. The reason the background cloud formation is working to create these resources. Clear? Then otherwise give admin access for the meanwhile. So now, if you can see here, the last important worker node is service. So we'll do the practice from Tuesday on all the components, horizontal HPA scaling, service, okay, pod, replica set, and everything. Theory is very important to understand. What is service, guys? Hmm? By using service, we can give the access. Okay. So Q proxy will communicate with service. Service, we have a type. By using service only, we will give the access application access to public. Access internal and external communication also, not only a public. Okay. So we have a three types of services. Three types of services. One is cluster IP, and second one is node port, and third one is load balancer. Okay. So here cluster IP will use for internal communication only. Internal communications. But node port, both node port and LB, we can use for external communication. External communications. So, but recommended way is load balancer. Load balancer only. Why? Yes. So node port, why we need to expose port number of IP and port number of your worker node? So better to go for load balancer only. So in this case, we can see how service will work. Okay. So let's go to AML file. Let's go to worker node. Service. Copy from here. These concepts are very, very important. Okay. Okay, guys. If you can see here, this is my deployment AML. Okay. And this is my service AML. Understand? So service will give access of your deployment into public or external or internal, whatever it is. In that case, if you can see, this is deployment AML. Already we seen how to create deployment AML. Service also same. First is what? API version. It is V1. Kind is service in place of deployment. Metadata, name of your what is service, and labels, your label services. And next is what? This is spec. Type equal to node port, port, target port, protocol. Just leave this time. I will discuss in one class. will give better clarity. What is port, what is target, okay, target port and all. Anyway, so first, how this service will link with your deployment. So if you can say this is deployment.yaml. So this is your service. Okay. Hmm. How service can link with your deployment to give access based on the label name. If you can see selector, the last one is what? Selector, my app NP. So based on this selector, it will work to communicate. Here, where is the label? My app NP. So we need to understand here this one. Selector. So it will communicate like this way. Even no need to define deployment service in one YAML file. You can write separately service file in the same directory, not in different directory. Okay. So you can write service different file, but both can communicate based on the label only, even if different files. I mean, no need to write your deployment.yaml, service.yaml in the same file. Even if you want to write multiple files, we need to start by giving 3 spaces. I mean, 3 lines here. Now, if I want to add anything, again, start for 3 lines and write a new service like that. Clear? So what type of service it is? Node port. If it is a load balancer, here load balancer will come. If it is a cluster IP, cluster IP will come. That's it, the difference. Clear? But very important, just prepare all the worker node components. Very, very important. If you get clarity here, we can easily do it all labs. Okay. So your work in the 4 days only for understand the worker node components. And if anything is pending from your, complete it. And the projects 3, 4 are there in my GitHub, right? Complete to push into ECR. We can call from here to deploy, right? Yes. So make it ready your images into your ECR, all projects. So if you can see here, so in my here, my repositories. So if you can go here, there is a project Maven. This is for Java project. This is for Node.js project. And one more Python project also there, right? Last one, na? Project Python is not here, na? See, plus project. 3 variations, 3 Docker files, different Docker files. Complete push your image into ECR. Make it ready your all images, 3 projects ECRs. And finally, we can do one project end to end. This is also end to end. But here, there is no database for these 3 projects. Our focus is to deploy only. And the last project, we can add database also here. I mean, our data is going to store in the DB. Clear? So, any questions from anyone? Sham. Sham is not responding. So if no questions means you can leave. So Terraform, I think it took complete many people. If you send after Sunday, na, I will not see your Terraform test paper answer sheet. I will resend to you. Okay. Yeah. Where Arun? Selector is empty. Where? No, selector is not empty. We have already given selector. See, Arun, selector is to select your service. See, for example, here there is no selector component. Just understand. There is no selector. If you are not giving selector here. So this service cannot link with your deployment. Understand? For example, the same deployment you can think without selector. This one also deployment will run, but your service will not communicate your deployment file if there is no selector. Understand? Arun, clear? Yeah. So selector is an optional one, but if when the server, label selector is not optional, if any other service is going to communicate your pod or deployment, in that case, selector is not optional. It's a mandatory field. Clear? Until you not specifying any labels, no other service will communicate with your pod or deployment or replica set. This is understanding. Anyway, we'll see the lab, right? We can do without label, with label, we can easily understand. Okay, guys. Online team, thank you so much. We'll meet Tuesday again. Bye.